Hello everyone and welcome back to my channel. So today we are going to start with the Class 6 NCERT for Geography, and we are going to start with the chapter 1, which is the Earth in the solar system. But remember, this will not simply be a summary of what is given in the book. We will cover all of the facts related to the solar system, be it the meteors, meteorites, comets, or what are dwarf planets, what is the criteria for a dwarf planet, what is the Goldilocks zone. So every possible question which can be asked in the prelims, we will cover that in this. So let us start with the video. So before we start with our solar system, let us understand this figure over here. So you can see we are standing on the Earth. Earth, which is a part of a solar system, and solar system, which is further a part of a Milky Way galaxy, and then Milky Way galaxy, which is again further a part of the universe. So what are the differences between a universe, a galaxy, a solar system, and a planet? Because Earth is a planet. So let us see that. So basically, the size is the criteria by which we have a distinction between these. So we live on planet Earth. Earth is part of the solar system, which is bigger than a planet. Then solar system, it includes the sun, which is our star, and everything that orbits around the sun, that is the planets. Then our sun, it is just one star in our galaxy, and our galaxy is known as the Milky Way galaxy or the Akashganga. And there are many such galaxies in the universe. So universe consists of millions and billions of stars and galaxies, right? So the universe is the biggest, the big one, and it contains everything that we know of. It was formed with the Big Bang. So there is a theory called as the Big Bang theory, which is given by Sir George Lemaitre. So Sir George Lemaitre say that there was a single dense point, and somewhere around 14 billion years ago, approximately, exactly these are 13.8 billion years ago. Okay, so approximately 14 billion years ago, this tiny densest particle exploded. And when it exploded, it gave birth to what we know as the space and time. And this explosion resulted in the formation of the universe. And because it was an explosion, everything started spreading out in different directions, and therefore it is said that the universe, even today, it is expanding. So universe even today is expanding because of this explosion, and we cannot reach the boundaries of the universe because it is ever expanding. So even if we try to move with a certain velocity, the boundary will also move with a certain velocity, and we would never be able to reach the boundary of the universe. Okay, so universe, it is the biggest one. It contains everything. Then comes the galaxy. Now galaxy is a collection of stars, gases, dark matter, which are gravitationally bound. So gravity is the force of attraction between two objects. Okay, so galaxy has those things which are attracted towards each other, so gravitationally bound. And dark matter is the matter which is not visible to us, okay, not visible to the naked eye. That's why its name is dark matter. But it is said that 85% of the matter that we know today is made up of dark matter, because scientists think that if there would not have been certain invisible matter, then there are certain phenomenon in the universe that cannot be explained. So therefore we name that the dark matter. So a galaxy is made up of all these things, and it is a smaller part of the universe. Now universe obviously consists of millions and billions of galaxies, right? And one such galaxy is the Milky Way galaxy, also known as the Akash Ganga galaxy, which is our galaxy where we live. Okay, now galaxies can be of 3 different shapes. It can be an elliptical galaxy, a spiral galaxy, or an irregular galaxy. Now, after the galaxy comes our solar system. So our solar system is present in the Milky Way galaxy. And we know our solar system consists of sun and the other planets. So let us move ahead. So where are we in? We are in this universe which consists of many galaxies, right? And galaxies consist of stars or constellations. We will learn what is a constellation, what is the difference between a galaxy and a constellation. And then finally we have our solar systems, and the solar system consists of many planets. And I told you, like the universe, it's ever expanding because, you know, in the starting, the Big Bang Theory says there was an explosion. So it is still expanding in all the directions. So all evidence that is available today, it tells us that there is only one universe. But there is a theory there can be many more of them which are invisible to us, because as I told you, we cannot reach the boundary of the universe, right? So there is a theory that says that, you know, there is no single universe. There are many such universes in the space, and that would make us a part of a multiverse. Multi means many, so many such spaces or multiverses. But that's just a theory. Now I told you we will learn about what is the difference between a galaxy and a constellation. So if you remember the definition of a galaxy, we talked about how a galaxy is a collection of those objects which are gravitational bound. Okay, gravity is one thing which is acting in a galaxy. But for constellations, if we are standing on the surface of the earth and we see the night sky, constellations are just the patterns of stars that are visible in that night sky. And these stars are rarely gravitationally linked. That means it may be the case that one star lies in one galaxy and the another one lies in another galaxy. So it may be in galaxy 1, it may be in galaxy 2. But we, as an observer on the surface of Earth, we make a pattern out of these stars because they are visible to us, and this pattern that we make is known as the constellation. So remember that it is only our line of sight that makes them look close together. It does not mean that they are very close together. It can be a case one of the star lies in galaxy 1, another one in galaxy 2. So they are thousands of light years apart. Light years. So what's a light year? Light year is the distance that light travels in 1 year. So by the name itself you can guess, light year is the distance that the light travels in 1 year. Now these constellations are patterns. So there can be many patterns that we can make with our eyes, right? So these constellations can be of various shapes and patterns. The most famous one is the Ursa Major or the Big Bear. Okay, and part of the Ursa Major or Big Bear is a smaller group of stars which is known as the Saptarishi, which is after the name of the 7 sages in the Vedas. Okay, Saptarishi, also known as the group of 7 stars. So you can see here, if I join these stars, it will form the shape of a ladle. Okay, and it consists of 7 stars, 1, 2, 3, 4, 5, 6 and 7. And in ancient times, people used to determine the directions during the night with the help of the stars. The North Star, which is also known as the Pole Star, which you can see here, it always remains in the same position in the sky, and we can find the North Star with the help of this constellation Saptarishi. So if you use the last two stars, also known as the pointer stars, okay, and you look straight towards the pointer stars and you extend this line of sight, then you will directly see the North Star, which always remains in the same position in the sky. Okay, and of course this is when you are facing north, because North Star is in North Pole, like pole star. Okay, let's move forward. Now we have some basic definitions of what is a celestial body, or what we call as the heavenly body. Okay, celestial body or a heavenly body. So these are all the objects or bodies which shine or are visible in the sky during day or night. So everything celestial bodies or heavenly bodies. Why heavenly bodies? Which are present in the heaven, or God has created them, right? Celestial bodies is a more scientific term. So sun, moon, stars, planets, meteors, asteroids, all of these bodies, they are known as the celestial bodies. Now out of these, what are the stars? Stars are those celestial bodies which have their own heat and light. So own heat and light. The biggest example, our sun. And they have large amount of energy. That's why they have their own heat and light. Whereas if we talk about the planets, these are those celestial bodies which do not have their own heat and light, and therefore they get their light by the stars. So they are illuminated by the light of the stars. So let's say this is sun and this is, say, earth or moon. Okay, so sun will have its light shined upon this planet or satellite, and it will reflect back certain light which gives it the light. So basically this illumination is because of the reflection of the sunlight. So such celestial bodies which do not have their own heat and light, but they are illuminated by the light of the stars and they revolve around these stars, such bodies are called as planets. So we will learn about the planets in our solar system like Mercury, Venus, Earth, Mars, etc. And we know that our solar system, for which the sun is the center star which has the highest energy. So all the planets revolve around the sun, and in total we have 8 planets. Okay, and if you look at the word planet, it comes from a Greek word planetai, which means wanderers. So they wander around the sun, right? And this term is known as revolution. So revolution around the sun, and then there is rotation. Rotation of a planet is around its own axis. So if this is Earth, this is the axis of the Earth, the rotation would be around its own axis, whereas revolution is on the orbit around the sun. Okay, now there is an interesting fact here. You can see that the 3 planets, Jupiter, Saturn and Uranus, they have rings around them. So these rings, so you will see Jupiter, Saturn, Uranus, they have certain rings around them. So what are these rings made of? These rings are belts of small debris. Okay, so all the small rocks and stuff, it surrounds that and it looks like it's a ring. So let's see, why do we call our solar system as a solar system? Okay, there are many planetary systems like our solar system in the universe. Okay, so there are many such planetary systems because we talked about there are many galaxies, right? And our planetary system is called the solar system because we use the term solar to describe sun. Okay, so it is named after the Latin word for sun, which is solis. And our planetary system, that is the solar system, it's located in an outer spiral arm of the Milky Way galaxy. So we already talked about it. Galaxies can be of different shapes. Milky Way galaxy is a spiral galaxy. Okay, now our solar system consists of our star, which is the sun, and everything which is bound to the sun by gravity, the force of attraction of the sun. to attract other objects towards it. So all the planets, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune, the dwarf planets such as Pluto, dozens of moons, millions of asteroids, comets, meteoroids, all of these form the solar system. The solar system also includes the Kuiper Belt. So a question can be asked, is the Kuiper Belt included in the solar system? We'll see a figure. Okay, so maybe here, yes. So you can see here we have the Sun, then Mercury, Venus, Earth, Mars, and then you see this belt over here, which is known as the Asteroid Belt. Okay, and after that we have the outer planets, Jupiter, Saturn, Uranus, and Neptune. And after Neptune we have the dwarf planet Pluto. And after Pluto, you will see there is another belt here which forms a part of the Kuiper Belt. So Kuiper Belt objects. Even Pluto is a part of the Kuiper Belt. Okay. So what is this Kuiper Belt? Kuiper Belt, it lies past Neptune's orbit. So you just saw here, this is Neptune over here, and beyond Neptune, Kuiper Belt lies. So Pluto comes under the Kuiper Belt. Now this Kuiper Belt is a sparsely occupied ring of icy bodies because it's very far away from Sun, right? So it will mostly consist of the planets which are made up of ice. And the most popular Kuiper Belt object is of course our dwarf planet Pluto. We will learn what is the criteria for considering a planet as a dwarf planet. Okay. Now beyond our own solar system, this one is an interesting fact. There are more planets than stars in the night sky. So star in our solar system, the star is the Sun, right? And we have the planets, 8 planets. But if we look beyond our own solar system, then there are more planets than stars in the night sky. And the Milky Way galaxy, also known as the Akash Ganga galaxy, it's one of the perhaps 100 billion galaxies in the universe. Now let us look at this figure over here. I already explained it to you. The Sun, which is the center of our solar system, every body revolves around the Sun in a fixed orbit. Okay, so we have Mercury, Venus, Earth, Mars, Asteroid Belt, Jupiter, Saturn, Uranus, and Neptune. Now I already told you the difference between the revolution. Revolution will be around the Sun in a fixed orbit. So for instance, Mercury will obviously have the shortest period of time for the revolution. It takes only 88 days. And as you move farther away from the Sun, because the size of the orbit increases, so therefore revolution days will also increase. The one spin on its own axis, which is also known as rotation, for Mercury it is 59 days. So that is of course not dependent on distance because it is on the planet's own axis. For Earth, you can see revolution, that's 365 days, and the rotation, which would be one spin on its axis, that's 1 day. Now let us look at some of the moons of the different planets. Mercury and Venus are the only 2 planets which do not have any moons. Earth have 1 moon, Mars have 2 moons, Jupiter, Saturn, maximum number of moons. We will see who surpassed whom in the number of moons in the next slide. Then Uranus about 27, Neptune have around 13 moons. Now these planets, they can be segregated into 2 parts. So you can see here inner planets or the terrestrial planets. Inner planets or the terrestrial planets or the rocky planets. Okay, by the name itself, you can guess terrestrial or rocky. So these are very close to the Sun. That's why they are called inner planets. And they are made up of rocks. That's why they are called as terrestrial or rocky planets. And then the outer planets, they are very, very far away from the sun. That's why they are called outer planets. And they are huge planets made up of gases and liquids. So they are also known as the gaseous planets or gas-like planets or the Jovian planets. Jovian means Jupiter-like. So planets like the Jupiter. Okay, so they are made up of gases and liquids, and they're very, very far away from the sun. So we have a total of 8 planets, so you can divide 4 and 4, right? In between, there will be the asteroid belt here. So Mercury, Venus, Earth, and Mars, they are the inner planets, terrestrial planets or the rocky planets. And then Jupiter, Saturn, Uranus, and Neptune, they are also known as the Jovian planets or the outer planets or the gas-like giants, right? Now, if you look at the sizes, you can clearly see Jupiter has the largest size. Then comes Saturn, then come Uranus, and finally Neptune, right? After that, we have Earth, okay? And Earth has a similar size as Venus. So after Earth comes Venus, then Mars, and then Mercury. So Jupiter is the largest. So it goes like Jupiter, Saturn, Uranus, Neptune, then Earth, Venus, Mars, and Mercury. That is the size-wise list. Now, apart from the planets that we have learned and the asteroid belt and the Kuiper belt, we also have some dwarf planets. Okay, we already know Pluto is known as a dwarf planet, so Pluto is one such planet. Now there is one planet which is inside our inner planets. So in between Mars and asteroid belt, if you can see here, this one is known as Ceres, and it is the dwarf planet. And then we have Pluto, we have Makemake, then we have Haumea, and then finally the Eris. So Pluto, Makemake, here we also have Haumea and Eris. And if you look at the sizes, the largest dwarf planet would obviously be Pluto. So Pluto is the largest one. Then comes Eris. And there is one unnamed dwarf planet. This is like the largest unnamed dwarf planet. It's named as OORT, and it was found in 2007. So it's known as 2007 OORT. After 2007 OORT, we have Haumea and then Makemake. And I already explained it to you. Inner planets, also known as the rocky planets or terrestrial planets. Then the outer planets, also known as the gas giants or the Jovian planets or the Jupiter-like planets. So we were talking about the moons. So recently Saturn has overtaken Jupiter as the planet with the most moons. So now Saturn has a total of 82 moons, whereas Jupiter has only 79. And if we look at which is the largest satellite or which is the largest moon in our solar system, this one is Ganymede, and Ganymede is one of the moons of Jupiter. Now you will ask, like, what is a satellite? So we will have a look at that too. Right now you can just remember Ganymede is the largest moon or the largest satellite in our solar system, and it is a satellite of Jupiter. Okay, and solar we have already discussed, related to sun god or related to sun, that's why it's called solar system. And there is some another facts here. Geo, which is meaning which means earth. Okay, and then we have different words attached to geo. If we attach logy, then it makes it geology, which is the study of earth. Then if you attach metry, so geometry is the measurement of earth. Metry is measurement, right? Then if we add oid at the end, it means something which resembles the shape or the form of the earth. So geoid is nothing but the shape of the earth, and we know shape of the earth is it's flattened at the poles, right? It's form of a, it's like a sphere, but it is flattened at the poles and it is bulged out at the equator, and that's why we call it a geoid. The shape of the Earth is a geoid. Now there is a trick to remember the 8 planets in sequence. If you do not know that, it's given in the NCERT itself. My very efficient mother just served us nuts. So M for Mercury, V for Venus, E for Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Now I told you Venus is sometimes considered as Earth's twin because its size and shape are very much similar to that of the Earth. And till recently, Pluto was also considered a planet, but there was a decision taken in a meeting by the International Astronomical Union in August 2006, and they said that Pluto, like any other celestial objects like Ceres, which lies between the asteroid belt and the Mars, and Ceres along with Pluto will be considered as a dwarf planet. We will learn what are the criteria for the dwarf planet in this very same video. So let's move forward. Now there is a figure over here. You can see everyone is revolving around the sun. So remember that all the planets, they revolve around the sun in an anti-clockwise direction. Anti-clockwise direction, which would be a direction like this. Okay, but only Venus and Uranus are the two planets that revolve in a clockwise direction. Then which is the biggest planet? So we talked about Jupiter is the biggest. It goes like Jupiter is the biggest, second is Saturn, then Uranus, then Neptune, then we have Earth, then we have Venus, then you have Mars, and then Mercury final. Which is the smallest planet? Of course, Mercury. Why does the Earth appear blue? Because 2/3 of the Earth's surface is covered with water. So if we see it from the outer space, so outer space will be the space outside of the Earth. Okay, if we see it from there, then the Earth appears blue. Now, why is life possible on Earth? Because the Earth lies at the perfect position. It is neither too hot nor too cold for the presence of water and air. And both of water and air are very essential for survival. But if you look at NASA's website, then you will see the only criteria for making it habitable would be liquid water. So Earth is just at the right distance for the water to be in the liquid form, and which is very essential for survival. So such a distance which makes a habitable zone is known as the Goldilocks zone. Okay, so there can be a question on what is a Goldilocks zone, and I think there was a question in the previous exams. So it is part of the hunt for water on other worlds, means looking for planets orbiting a certain distance from their stars. So planets in this zone, they are neither too hot nor too cold. Conditions could be just right for liquid water. And we have found one such planet like Earth, which is at the perfect distance from its own star. So it's obviously present in some other planetary system. This is known as the Kepler 186f. Okay, so Kepler 186f in its planetary system is just like we have Earth here in our solar system, just at the right distance for the water to remain liquid. So a celestial object can only orbit so close, like Mercury is very close, Pluto is very far. So if it is very close, the water on the surface will boil away. If it's very far away, then the water would freeze. So Goldilocks zone is basically the habitable zone. So it is that range of distance which have the right temperatures for water to remain liquid. So I told you, just like Earth-sized planet have been found in another planetary system, which is known as the Kepler 186f. So it's an exoplanet. So we will learn what is an exoplanet. It's basically the planets which are outside our solar system. So it's orbiting a red dwarf, which is the sun for the Kepler 186f, and it's about 580 light years from Earth. So again, light years, the distance that light travels in 1 year. Okay, so I hope Goldilocks zone is clear. Let's move forward. Okay, so we talked about the Kuiper Belt, and we talked about how Pluto is a part of the Kuiper Belt. Now we will discuss what lies beyond the fringes of the Kuiper Belt. So beyond the fringes of the Kuiper Belt are the OORT clouds. So what are these OORT clouds? They are like a giant spherical shell which surrounds our solar system. So if this is our solar system, this is our sun, right, planets. Then OORT cloud is a giant spherical shell which surrounds our solar system, and it has never been directly observed, but of course its existence is predicted by the scientists on the basis of some mathematical models. And it's said that OORT cloud, it is made of again icy pieces of space debris. Now again icy pieces because it's very far away from the sun, and some of these icy pieces, they are bigger than our mountains on earth, and they are orbiting our sun. So remember, OORT clouds are also, it consists of the space debris which is also orbiting our sun. Now this shell of material is thick and it extends from 5,000 astronomical units to 100,000 astronomical units. So what is an astronomical unit? One astronomical unit is basically the distance from the sun to the earth, which is 150 million kilometers. Okay, so remember, if we talked about light year is a distance light travels in 1 year, and one astronomical unit is the distance from the sun to the earth, which is, we know, 150 million kilometers. Now the OORT cloud is basically the boundary of our sun's gravitational influence. That means that the orbiting objects which are present, in the OORT cloud, they can turn around and return closer to the sun. The effect of the sun's gravitational force is not felt beyond the OORT clouds. Okay, so it's not felt beyond the OORT clouds. Anything in between the OORT clouds will orbit the sun. But why? Because of the gravity of the sun, because of the gravity of our star, the sun. But if we go beyond that, the gravitational influence ends. Okay, so let's move forward. So we talked about that Ganymede, which is one of the moons of Jupiter, is the largest moon, or is the largest natural satellite. So what is a satellite? A satellite is a celestial body that moves around the planets in the same way as planets move around the sun. So we learned about Mercury, Venus, Earth, Mars, so on. They are orbiting around the sun, right? But there are some bodies that move around the planets, just like the planets are moving around the sun. So such bodies, such celestial bodies, are known as satellites. The most common example that we know of is our moon, the Earth's moon, because Earth has only one natural satellite, which is the moon. Okay, now apart from the natural satellites, nowadays of course we make some human-made satellites. So it's an artificial body which is designed by scientists, and this is designed so as to gather the information about the universe, or we use it for our communication purposes. If you have seen the video on the Antarctic program, please tell me which is the agency which downloads the data from the Indian remote sensing satellites. Okay, so please name that agency in the comment section below. I explained it to you in the Antarctic video. Okay, so you can just check that, which is the agency that downloads the data. Okay, so these satellites, they are obviously human made for our own purposes. Some of the examples are given: IRS, EduSat, INSAT. Now if we talk about moon, then of course it is the only satellite of the Earth. Its diameter is 1/4 the diameter of the Earth. Distance from the Earth is 384,400 kilometers, and it takes 27.3 days, or approximately 27 days, to make one revolution around the Earth. So revolution is around the Earth. And there is no water and air on the moon. The lunar surface, that is the moon surface, has mountains, it has plains and depressions, and due to those mountains, they cast shadows on the surface of moon. There are lots of craters as well, right? And one of the most important things is, if we see the moon, we are never able to see the back side of the moon, which is also known as the far side of the moon. So we always only see one side, or the front side of the moon. We cannot see the back side. Why is it that? Because the moon, it takes around 27 days to move around the earth, and it takes exactly the same time to complete one spin. So after one spin and one revolution, it is, again at the same position, and we see the same side, which we were seeing earlier. So only one side of the moon is visible to us on the earth, and we cannot see the far side of the moon. So recently a country has sent a mission to study the far side of the moon. So you have to comment in the comment section below which mission was it which is going to study the far side of the moon. Okay, let's move forward. Now these are some of the facts they're given in NCERT, but most of us already know that. Like, the moon may appear at different times, in different shapes, in different positions in the sky. The full moon, it comes only once in about a month, and that is known as full moon night, or what we call as the Purnima. And a fortnight later, you cannot see it at all. That is the new moon night, also known as the Amavasya. So when there is no moon, right? And of the 8 planets, Mercury and Venus are the only ones with no moon. So we already discussed that. And Saturn has surpassed Jupiter with the maximum number of moons. So Saturn has 82 and Jupiter has 79. And then Pluto, which is smaller than our own moon, it has 5 moons in its orbit, including the Charon, which is a moon so large it makes the Pluto wobble. Okay, one of the moons of Pluto is so large that it makes it stagger from side to side, so it makes it wobble. And even tiny asteroids, they can have moons. It's all about the gravitational effect, which one has more gravity. Now, do you wonder why can't we see the moon and all those bright tiny objects during daytime? Of course, the answer is sun, because the bright light of the sun does not allow us to see all those bright objects of the night sky. Okay, let's move forward. How our solar system was formed. So I told you around 14 billion years ago, there was a big bang. Okay, there was an explosion, a big explosion by which the universe was formed. So the gases, the interstellar gases from the stars, okay, so if any star dies, then it leaves behind dust and gases. That's called the interstellar gases and dust. So there was a dense cloud of this interstellar gas and dust which started to collide, or collapse, ultimately forming our solar system. Okay, so when this dust cloud, interstellar gas dust cloud, it collapsed, it formed a solar nebula. So nebula, why is it called a nebula? Because it was spinning, swirling disk of material, and because it was spinning, so due to gravity pulled everything, more and more material which was heavy in the center. Okay, so at the center, gravity pulled more and more material in, and eventually the pressure in the core was so great that hydrogen atoms, they began to combine and form helium. So if somebody asks what were the first atoms in the universe, hydrogen atoms, and they started to combine and then form helium, and that released a tremendous amount of energy, and with that our sun was born. And after that, this material, swirling disk of material, center we had the sun, then there was still some material on the farther sides of the disk, and it's also started clumping together to form larger objects, and that's how planets and dwarf planets and moons came into being. And there were some leftover pieces which became the asteroids, which are in the asteroid belt, right? comets, meteorites, and some small irregular moons. Now, if we see the structure of our solar system, then of course I told you the heavier material got inside, right, at the center, so nearest to the sun. That's the reason we have the rocky material there, the heavier material there. So the first 4 planets, Mercury, Venus, Earth, Mars, are known as the terrestrial or the rocky planets because they are made of more heavy material, solid rocky surfaces. Meanwhile, materials such as ice, liquid, or gases, they settled in the outer regions of this young solar system, and gravity pulled these materials together, and therefore the gas giants like Jupiter, Saturn, they were formed. Uranus and Neptune were the ice giants. So you can see Jupiter and Saturn, they have mostly the gases around them, whereas Uranus and Neptune, they have mostly ice on them. So they were separated out like this. And that's why, like Jupiter, Saturn, Uranus, Neptune, they're also known as the outer planets. Now, the dwarf planets, I told you, with the exception of Ceres lies between Mars and the asteroid belt. So this is Mars, okay, and this is Jupiter, and there was this asteroid belt here. So Ceres lies between Mars and the asteroid belt. Okay, except for Ceres, okay, which is in the main asteroid belt, other dwarf planets, they are very, very far away, okay, so beyond Neptune. So we know Pluto, then we learned about Eris, Haumea, Makemake, 2007, OORT. So this was the size, if you remember. Now here Haumea, it has an oblong shape, so you can see the shape for the dwarf planet Haumea. Okay, so it's wider on its longer axis as compared to 2007 OORT, but its overall volume is smaller, and therefore OORT is the larger planet as compared to Haumea. Okay, and I told you 2007 OORT does not have a name, right? So it is the largest unnamed dwarf planet in our solar system. And then to study Pluto, okay, spacecraft visited Pluto. So NASA's New Horizons spacecraft visited Pluto to know more about it in 2015. So we generally, see these dwarf planets through the Hubble Space Telescope or the Kepler telescope, but with even very powerful telescopes, we are not able to see what's on the surface of these dwarf planets because they are very far away, they are small, and they are very cold. So it makes it very difficult to observe them. Okay. Now we are talking about dwarf planets and planets. What are the differences between a planet and a dwarf planet? So there are 3 properties that make a dwarf planet, and in 2006 International Astronomical Union gave these characteristics. So according to them, a dwarf planet is that celestial body, number 1, that orbits the sun. Number 2, it has enough mass to assume a nearly round shape or assume hydrostatic equilibrium. So hydrostatic equilibrium is, when it's pulled from all the directions equally, and ultimately if it's pulled from all directions equally, it will assume a nearly round or spherical shape. So it has enough mass to assume a nearly round shape. And third one, it has not cleared the neighborhood around its orbit and is not a moon. So if this is, say, a planet, okay, and if I ask you what will be the 3 properties of a planet, 2 of them are same. Okay, so the first 2, planet orbits the sun. Yes, it has enough mass to assume round shape. Almost all the planets, if you see, they assume nearly round shape. So that is also correct. But the third property is where these planets and dwarf planets differ. Okay, planets always clear their neighborhood, so there is nothing near the neighborhood, but a dwarf planet will not be able to clear its neighborhood. There may be some debris here, there may be, some asteroids and things like that, rocky debris there. So a dwarf planet is not able to clear the neighborhood around its orbit. And it is not a moon because it's not orbiting any planet, it's orbiting the sun. So therefore it makes it a dwarf planet. So remember, the difference between a planet and a dwarf planet is only that a planet has cleared the neighborhood around its orbit, whereas a dwarf planet has not cleared the neighborhood around its orbit. And that's why Pluto orbits around the sun. Yes. It has a nearly round shape. Yes. But does it clear the neighborhood around its orbit? No. And that is why it is a dwarf planet. I hope that's clear. Now there are some interesting facts that were given in the NCERT. Like, I think everybody would know that light travels at the speed of 3 lakh kilometers per second, and with this speed, even the light of the sun, it takes around 8 minutes to reach the earth. So light of sun, it takes around 8 minutes to reach the earth. Then Neil Armstrong was the first man to step on the surface of moon on 20th of July 1969. And then those people who study the celestial bodies and their movements, they are called as astronomers. Aryabhat was a famous astronomer of ancient India, and he said that the moon and planets shine due to reflected sunlight, and today we know that is true. Okay, now let us see what are asteroids, what are meteoroids, meteors, or meteorites. Now asteroids, they are tiny bodies that move around the sun. So just like planets and dwarf planets, they also move around the sun, and they are found between the orbits of Mars and Jupiter. So if you remember the asteroid belt, they're mostly found there. And scientists, they are of the view that asteroids are part of a planet which exploded many years back, because obviously it is in between the main belt, right? Between Mars and Jupiter, there is a belt. So it may be the case it was a planet earlier, but it exploded and got, shredded into tiny pieces, which are known as asteroids. That's why it's the asteroid belt now. Then we have meteoroids. Meteoroids are also small pieces of rocks which move around the sun. And sometimes what happens is these meteoroids, they come near the earth and tend to drop upon it. But due to the friction with the air as they enter the atmosphere, there is a friction between that piece of rock and the air, and they get heated up and they burn themselves. And it causes a flash of light when they burn, and this is known as a meteor. And sometimes a meteor is not completely burned, okay, it survives the friction of the air, it's not completely burned, and it falls on the earth and creates a hollow, and then it is known as a meteorite. Okay, so it's known as a meteorite afterwards. So if we see here, meteoroid are the objects in space that range in size from dust grains to small asteroids. So they are like space rocks. When they enter the Earth's atmosphere or that of another planet like Mars at high speed, they burn up due to friction, also known as the fireballs or the shooting stars, or what we call as the meteors, a flash of light. Then if a meteoroid survives a trip through the atmosphere, or a meteor survives the trip and hits the ground, it's called a meteorite. Okay, so you can see here various things. Asteroid is a rocky body which is smaller than a planet and it orbits the sun. It lies between Mars and Jupiter, the asteroid belt. Then we have the comet, icy body that releases gases as it orbits the sun. So we'll learn about what's a comet. Meteoroid is a rocky metallic fragment of asteroid, comet, or planet, and if it reaches the ground of the planet, it's a meteoroid. If it burns up, gives a flash of light, it's called a meteor. Okay, let's move forward. What is a comet? So comet are basically snowballs. That means they are made up of ice, of frozen gases, rock, and dust, and they also orbit the sun. So when they are frozen, they are the size of a small town, like they're very small. But when a comet's orbit brings it closer to the sun, what happens is it heats up, and due to that heating up, it spews up it spews some dust and gases, and a giant, light comes out of it. So you can see here light coming out of a comet. Okay, so basically a comet is a small icy solar system body, and it orbits the sun. But when its orbit gets it very close to the sun, it begins to warm up and it begins to release gases, a process that is called as the outgassing. Okay, and due to that we see a light here, a tail. Okay, so it's basically, if we see the parts of a comet is made up of 3 parts. Okay, the center, which is known as the nucleus. So see here, this one is the nucleus. The nucleus is surrounded by a certain visible atmosphere of dust and gases, which is known as the coma, the icy dust and gases. And then due to the effects of the solar wind or the sunlight or the solar radiation, some of the gases and dust from the coma, they are spewed away by that solar wind or sunlight, and they form these tails over here. Okay, so this one is the iron tail, giving the glow, giving the light, and then there is a dust tail separating the dust. Okay, so comet has 3 parts: nucleus, coma, and tail. And tail can be an iron tail, which gives the glow, and the dust tail. I hope that's clear. Now comets, again, remember, they are also orbiting the sun. That's why when they come closer to the sun, they heat up and they spew up the dust and the gases into a giant glowing head. Okay. Now the last topic is, what is an exoplanet? So an exoplanet is any planet which is beyond our solar system. And most of these planets, they orbit other stars, but it's not important. Some can be, freelance planets. So free floating exoplanets, they are known as the rogue planets, and they do not orbit any star. They orbit the galactic center. That means the center of the galaxy. So there are some stars which will orbit the center of our galaxy. And if you want to know, like the center of the Milky Way galaxy, recently it has been discovered, it's a small black hole. So black hole, it absorbs everything around into itself. It has very high density. Okay, so our Milky Way galaxy, it is spinning around this small black hole. Okay, so exoplanets, some of them, they orbit around stars, but some of the exoplanets do not orbit around stars. They orbit around the center of the galaxy or the galactic center, and these are known as the rogue planets. Okay, and we have NASA's Kepler Space Telescope, which tells us that there are more planets than the stars in our galaxy. The best example of a system that is found is the Trappist-1 system. So just like we have our solar system, there is another system which is named as the Trappist-1 system, and it's about 40 light years away. And there they have found like 7 roughly Earth-sized planets, and they are orbiting a small red dwarf star. Okay, so that is it about the solar system. I hope you liked the lecture, and if you do, then please do not forget to subscribe the channel, leave the comment below, and please like or unlike the video. Thank you so much for listening. Have a very good day.